All right, so today we want to talk about the transport layer, that layer that is on the OSI model in detail for the class ITEC 250. All right, so in discussing the transport layer, we want to talk about the difference between TCP and UDP communication, Transport Commission Protocol or Transmission Control Protocol, TCP, and the UDP, User Datagram Protocols. We need to understand the difference between the both of them. When we're talking about TCP, Transmission Control Protocol, we look at the three-way handshake, and we're going to talk about the three-way handshake in great detail. We also talk about TCP sequencing numbers and acknowledgements and TCP windowing. I'm going to show you some examples of what this means. So the overview of this course is what we're going to learn here today is the transport layer of both the OSI model and the TCP models is very important. At this layer, the data being prepared to be sent over the internet is broken into pieces, otherwise known as your PDU segmentations or segments. The PDU or the protocol data unit at the layer is called segments. There are two main protocols that function at this layer, the transport layer, which is TCP and UDP. TCP or Transmission Control Protocol is a very reliable and connection oriented protocol. TCP is characterized as being reliable because of the fact that it utilized what is considered as the three-way handshake. Has first been established, it's used sequence numbers to track all segments, and it is also used systems of syncs and acks. We're going to talk about that, the acknowledgements, and it will not send new data until an acknowledgement has been received for data already sent. If this acknowledgement is not received, the data will not be resent. And I need you all to understand how important the three-way handshake is in terms of the syncs and acks, and we're going to show some examples of these. The user datagram protocol, however, on the other hand, is not reliable. It is best effort delivery, and I want you all to take into consideration what I'm saying there. It is best effort delivery. It is otherwise known as a connectionless protocol. Connectionless protocol that does not require an established connection with another computer before sending data. So we'll talk about that in greater details. User datagram protocol advantages is that the fact that it is header fields or control information is a lot smaller than TCP because TCP has a bigger header field. As there's a lot less to process, and as a result, it is faster but less reliable protocol. It does not mean that the entire there's no checks and balances when it comes to UDP, but TCP there does. All right, so we did a little graph here to show you all the difference between TCP and UDP. It is connection based, session based, built on connections. The UDP is connectionless. TCP use sequencing of numbers. When you talk about the sequencing of numbers, UDP is best effort delivery, and I'm going to explain what I mean by that. TCP is very reliable and UDP is very unreliable. And we see the differences between where these two protocols will mesh and what is the two protocols is best used for. All right, so one of the questions is that why would you want an unreliable protocol? And to explain this, to have an unreliable protocol, we see two diagrams here of UDP, which is a computer that is sending information to the server, all right, where TCP acknowledges the three-way handshake. So I'm going to explain this in detail for you. Where UDP is in television and streaming production, radio, television, and so on, they use UDP. So basically, if I comes into a classroom and I say, who book is this belong? And I just rest the book and walk off sign, I didn't acknowledge to know who the book belonged to. If somebody was the owner of the book, I just say social studies book, whoever belonged to, take it. I didn't even acknowledge that. That is UDP. Where TCP now would wait for verification. All right, this is your book. Okay, show me some ID that this belongs to you, and so on. Right? So this is the difference between TCP because it involves the three-way handshake, where UDP will just send the information, and they didn't care less whether or not if the information is sent or not. And television production is important because you don't want to have a three-way handshake when you're watching a movie, because every time a packet is dropped, the movie is going to start over. So at UDP would have a continuous flow. So in talking about the three-way handshake, the first thing that needs to do is when you send an ICMP message request where you consider as a ping command, it is going to send what you consider of a sync, right? And the server now receiving the sync is going to acknowledge that it receives the sync, all right? And then the computer that did send the information afterwards, at making the third level of the three-way handshake, would send the acknowledgement and start sending data. So this is why it's considered as a three-way handshake. You need to communicate to make sure that a sync went first, the sync is acknowledged, and then you acknowledge back the response from the person who you send the message from, and then data will start to transmit. And we're going to talk about sliding windows when we come in our next couple of slides. All right. So this is how it is normally work here with more on TCP communication. We have a sync that will be sent across, right? And what happens here, and I want to be able to pay attention, it is going to acknowledge and it will increment the acknowledgement as 1 and send back the packet with a sequence of 5. You will acknowledge sequence 6 because you acknowledge it, and you will acknowledge as well 11, and you will now send 12 and 6 because you would increment here by 1 and you'll send across. And this is the reason why the whole three-way handshake is developed. All right. So again, if your number is 9 or 5 or 4, whatever the case may be, when it comes across here, the server would acknowledge one number that it will increment, and it will send its own number where you would increment on that number, right? And that number would correspond to the same number that was sequenced over from the acknowledgement, and then you would send back a new sequence which will be able to be increment, and then this acknowledgement over here will take the sequence number of here. Basically what is happening is that it is now going to get ready to send data. All right. So in this diagram here, you all could probably follow it out, and again, as the same thing I say, if I send 5 here, this would be 6, right? Then I would send it back across. So I'll be sending 6 and a sequence number coming across. And if you just say I send a sequence number 4, then you acknowledge 5 and you receive 6, right? And so on. And this is how the TCP windowing, it starts to sending data. But this basically technology incremented, because this means that data is being sent 1 byte at a time. So this one here now we call the TCP windowing, where, for example, and I'm going to explain this whole concept for you. Let me just say Matthew is at the end of the class, and I decided to send one ball to him, and he catch it. Then I'm going to increment it by 2. He catch 2. I'm going to increment it by 4, and he catch 3. The sliding window would remain at 3 because he did not catch all 4 balls. And that is how the TCP windowing is established. So in this case here now, I put some numbers in it in terms of sliding windows. Again, with the same concept with the ball. I send 1, he catch the ball. He acknowledge 2, right? So I've got sequence 2, I send 3, he acknowledge it. So he sends 4, right? I got the 4, right? So I send 3 other packets to make 4 now. He acknowledged 7, right? Then now I send it now, but what happens is he did not acknowledge 7, 8. This in this case would have been 7, 8, 9, and 10. He only catch 3 balls instead. So this acknowledgement here would have been 11, but he only accept 3 in this case. So the sliding window would remain at 3 packets going across. So basically, explaining the whole concept of the sliding window in this area here, it's like when you're transferring data from one PC to the next, or from a hard drive or flash drive to the PC, you would see that the data going across like in a window. It will start with saying, oh, cool, 200 megs, it will take an hour to transmit. Then after you see the time going down, 1 hour, go down a little bit, 30 minutes, it going down again, 20 minutes, it going down again, 10 minutes. And then we realize that it reached 10 minutes, it say, nah, some packets get lost in between because of segmentation. Remember, segmentation is the whole concept of acknowledging the sequence numbers, and it realized that it will transfer at 15 minutes. In 15 minutes, it will stop at 15 minutes and it will continue transferring at that speed. So you could try it out on all too. You understand? When you are sending data across from your flash drive to your PC, you'll see at one time it's plenty time. And then at another time, you just see the time going down and it will go so far down. And then it will come back down and come back up a little bit and stabilize. So basically, it might start an hour, keep on going down, going down, going down, and it might reach 20 minutes. And it try again and go down and reach 10 minutes. And then you'll see from 10 minutes, it's going up to 15. That means that the sliding window cannot operate at 10. It could only operate at 15 minutes. And it will stay there at 15 minutes. And this is a typical example here of a sliding window. That is how files are being transmitted. And because of TCP and the segments that being numbered with their headers, it want to make sure that all the segments are placed together. Right? So in reviewing your transport commission, your transport layer, because we talk about basically both the TCP IP model, right, and the OSI model, we see here that the transport layer moves data between application or devices on a network. So it is important for that. Basically, be it IP telephony, which uses user datagram protocol. We have the television, of course, and then we have data on the computer system that we use the TCP um, protocol for the three-way handshake. All right. So in basically when we're looking at this diagram here, we see the transport layer segments the data, right, at each level, right? So this is streaming here, so this is UDP, and you need to identify the protocols that we use. All these here will be TCP, right? Separation of data from different applications. So this is what TCP does, and multiple applications running at once. You understand? It's like an interleaving process that taking place now. So your email, the web browser, they would be using TCP because they need to make sure and have the transmission control protocol being in effect. And IP telephony, voice over IP, and streaming video would use user datagram protocol. It is important for you all to understand that all these multiple applications would be simultaneously interleaving on the network itself now. All right. So even though you have multiple web pages open, you would see that the transfer layer divides the data into segments, all the data into segments, right? That are easier to manage and transport because you can't just take a whole file and carry it across. Like if you're taking a ton of bricks and carry it across. No, just take one brick at a time and it will reach and you will be able to transmit all of them going across that particular network. All right. So again, in detail, we have to pay attention to segmentation, which allows session multiplexing. And I like that whole concept of multiplexing and multiple multiplexing two of applications can use the network at the same time. I like to refer to it as interleaving, right? We have data segmentation, which facilitates data carriage by the lower network layer. We will talk about the IP layer. I'll do a video on that. It also have error checking. So at the TCP, error checking is there. You understand? To make sure that each segment is intact. So error checking is extremely important for TCP, whereas in UDP, you would not get that. And hence the reason for the transport layer and the functions of that particular layer itself. Right, so it's establishing this thing, and it's very important for you all to know these things now. What does the transport layer signify? Is establish a session, establish the application is ready to receive the data through the three-way handshake. It must establish a session, of course. A reliable delivery, TCP. Transmission control means lost segments are resent, so the data is received complete. So if a block is broken, another block is going to be taken up from the hardware and put back in place to make sure all the data is fully received. Of course, same order delivery ensures that the segments are reassembled into the same proper order, and of course, flow control. Manage data delivery if there is congestion of the network. Of course, we will talk about, broadcast storms and so on. That could be any network. Some of you are using B Mobile, for example, who the network is extremely slow versus those who may be using a faster network and so on. So these actually come in exams, transport layer. Establish a session and after they give it the details what it means by establish a session and give an example using the three-way handshake. Give an example also it must establish a session too with UDP because it must establish a session with video or with IP telephony or with the radio. Reliable delivery, you need to talk about reliable delivery, and at the same time you mentioned TCP and you mentioned the reliability of the delivery to a certain extent in terms of best effort delivery when it comes to UDP. So you have to get into a little explanation when you're talking about it as well. All right. So again, we look at the OSI model and we look at the TCP model, which is a resemblance of the both of them have transport layer. You see the requirements of this here, which is user datagram protocol on this side here, and TCP on this side here. You will see on is a required protocol for these IP telephony and streaming video. It is extremely fast, low overhead, does not require acknowledgements. Lovely. Does not resend lost data. Of course, you would not want to send lost data if you're watching a movie. All right, delivers data as it arrives. So however it arrives, that's it, it deliver. Right. Whereas in TCP on this side here, it requires a protocol, of course, for both these models, email and the web browsing. It is extremely reliable. It acknowledges data through the three-way handshake. It resends lost data, you understand, and delivers data in the same order it has sent. So this is how important the transport layer is both on the TCP and the OSI model as the application developers choose the appropriate transport layer or protocol based on the nature of the application. And again, as I said, when it comes to IP telephony and streaming video, however the data is received, it just moves on. You don't want to be watching a movie and then it forget a part in the start, and next thing, sometimes when you're watching a movie, you see, like you're watching a couple of them, but I didn't see this part. You understand? Because that part probably must be was missed out. That data was not reliable, whatever the case to be, and so on. You can't just expect a piece of the movie to just pop up from the end when it's supposed to be in the beginning, and so on. All right, so that is the difference between UDP as well as TCP as against TCP. So we're looking at this, and you will find this using Wireshark, right? You see the TCP headers, and I'm going into very detail. The headers are 20 bytes. Source and destination port is identified. A sequence number is going to be given when before it starts the transmission. The window here, as we talk about the urgency of the window, the sliding window, 16, meaning that this is the number of packets could be sent according to whatever communication that the two applications would have arrived at. You understand? And so on. So this is some of the things here that you have to know, especially the sliding window, the acknowledgement number, the sequence number, and so on as well. With user datagram protocol, you'll see that the two sessions here are established, just the length, and that's it. Full stop. All right, 8 bytes and moving on. All right. So again, I would like to get into a little bit more detail in the TCP connection because this is extremely important, especially when we do the exercise on packet tracer. All right. And I will hope to have packet tracer open. I will just have it open in a little bit. So basically, you send a sequence of number of 100. Right. So the sync arc was received. Right. So of course, this 100 now will increment as an acknowledgement of 101, and you would send the a sequence of 300 in this case here, which you would be the transmission here. So when you come over here, you would receive back your ARC, which is 100, but you would increment of the acknowledgement of the three-way ASIC as being established as 301, and then you will determine in your TCP header your window size. All right. So again, this is a picture that I took out of the three-way handshake using Wireshark, and you could install Wireshark. Make sure when you install Wireshark, you use WinPCAP2 as well. Install that, and let me just analyze the data here. TCP. So you see the TCP protocol here. I've sent a sync arc. You understand? You see the sync arc, what is the TCP IP address? It went to 254, and the number here is 1069 as the protocol report. Let me see what is 254 here. Look, 254 is over here. So you see acknowledgement. You see 1064 here. You can acknowledge the IP address of 10.1.1. Right? So right here in this essence here, you could see at the bottom here the sync, right? Destination, the protocol that is used, the port that is used to as well. This is a web browser because it's port 80. You see the header here is 28 bytes per whatever. You understand? So this is how you when you're using Wireshark, you would literally learn how to read these things, and you can install Wireshark, and you would just do a regular like a test between two PCs, and you will get the information that popping up here. That's one of the things that I love about Wireshark. All right. So again, UDP, low overhead data transport. However, it receives, it does not establish basically a connection before establish sending data. It just sends the data. All right, sends it over the network. Same thing with IP telephony, as well as voice over IP, as well as streaming data and so on. So UDP provides low overheads data transport because it has a smaller datagram header and no network management traffic because it just send as it is. So here I have a what you consider as the same thing that we talk about: segmentation, reliability, connection oriented, source and destination port flow control. We could see here that it uses segments here, sequence numbers acknowledgement, so that will be in your header. UDP now has datagrams, no sequence numbering. Understand? Few header fields, little overhead, is extremely fast. Reliable due to sequence numbers. I had to talk about these things when you're doing the exam due to sequence numbers, and it resends of data if no acknowledgement is received. Unreliable in terms of it sends as it is. However, it receives, it connects, whoever. It connection oriented because of the three-way handshake. This is connectionless because there is no handshake. Right, source and destination port, of course. Source and destination port would have to establish the both of them, so there's a similarity. Here has no flow control, but this here has flow control because you have to deal with the window size, the same TCP window in as it wouldn't overwhelm. I remember I tell earlier, going down to 10 and come back to 15 and so on. Same thing here again. It builds connections. We had this slide a little earlier. I'm just reintroducing it again. It is connectionless in this in UDP. Sequencing of numbers, TCP, of course, best effort delivery. And we know what it means by best effort delivery, or however it sends, it receives. TCP again is reliable, and this one here is considered as unreliable. Right, so we're looking at transmission control port numbers, and you can literally go on the website to identify well-known port numbers. We know some of the port numbers already, port 80 and so on. We know some of the port numbers, especially. So this here, if you go to the organization here, let me see if I could copy it, right? Reload it up, you would see all the different port numbers. I'm gonna just allow that to load for meanwhile. All the different port numbers. All right. Let's close down this. I will need this service. All right. Look at here, the registry of all the different port numbers here. It have games inside of here too, so you could click it and see it now. All these port numbers is assigned: FTP 20 and 21, Telnet 23, SMT 25, all these things, and then have other port numbers. So these are the global port numbers database here, and a UDP is uses 64, TCP in this case here. All right, so you could just browse through the list, and not really for you to learn these things by heart, but at least you must know FTP, port 80, for HTTP service, FTP 20 and 21. At least you must know these things, just to show that you learn something, man. So again, this is it here, the registry. I just take a picture of it. This is how it used to look before. It's updated, and this is what I'm using. The command prompt, and I just decided to type a command here to show all the TCP sockets. That's netstart was the command that I use, right? To show all the the connections I would have and the establishment. Trust me, you wouldn't believe a lot of things is be going on in the background, especially when you load an application. You see, I have Adobe here open, so Adobe continuously communicating to make sure that the software that I have is not pirated and so on. See all these different connections here. All right, these are the ones that you should know: TCP and UDP. Port 21 FTP, SSH 22, 23 Telnet, SMTP 25, DNS Server 53, HTTP 80, POP3, which is Post Office Protocol, 110, HTTPS, which is secure HTTP, DNS for 53 and UDP, and 69 telephony TFTP port numbers. Right, so these are some of the port numbers you should just know overall. All right. So you see how detailed this is here. Again, your port numbers here for your post office protocol for your electronic mail. This is the post office. When the mails come through the SMTP service, it must go to your post office to sort the mail properly. We have port 80 for HTTP, HTML, and then internet relay chat. They use the application. The port number would be 531. Right. Again, look at the example here of it. You have registered ports here for Cisco. Right, so basically everything is registered, even games and all ports are registered. So these are just the summary of the port numbers that you should know: DNS, POP3, SMTP, SSH, FTP, Telnet, and HTTP. It may arrive in the exam online, so you should know it. So with this activity now, we want to be able to build this. So let me just kind of like go to my window here and look for Cisco. And I may have to sign in. Hopefully, I may not because it's not 3 months as yet. All right, so we're looking at 224 and we want to just connect these machines. You could do this in Cisco Packet Tracer. All right, let me see if Cisco Packet Tracer has been loaded as yet. Right, it is loading up. All right, what I will do is probably go across here on this screen instead.